All right, for this problem we need to place our point of interest on this line. So they tell us that the point we're interested in is 1 centimeter to the left of the middle charge. So that would be something like that. And I'm going to call this point P, right here. That's the point I'm interested in, knowing the electric field. So just like force, the electric field needs to be added up. So I need to find the electric field. If I can get off of there. I want to find the electric field at point P due to this charge, at point P due to this charge, and at point P due to this charge. And so now the electric field, E, the equation is equal to KQ over R squared. So that means that each of these charges has a field. And so if I think about this charge right here, it has a field that looks like this. Because it's positive, it has a field that looks like this, goes away from the charge, like that. And so if I think about my field at point P, right, this field, or this charge has a field that points away from it. So I know that the field at point P due to this charge is going to be in the positive x direction. Now what about this charge? This charge also has a field that looks like this. And so here my field is pointing away from this charge. So that means that I'm going to have a field that goes in the negative x direction here, pointing away from this charge. So this charge, it's going to be positive. This charge is going to be negative. Now what about this charge? So this is positive charge. For a negative charge, I have a field that points towards the charge. So we can see that here, if my field is pointing towards the charge everywhere, then my field here is going to be pointing to the right. So I'm going to have a positive x direction for this charge, a negative x direction for this charge, and a positive x direction for the third charge. Okay, so we need, because all these charges are on the x-axis and we're only interested in the point along the x-axis, then I don't have to worry about the y component. So I'm just going to think about my electric field in the x direction. So my E field at point P is equal to E, let's see, that. E due to 1, we'll call this one 1, Q1, this one Q2, and this one Q3. So we'll call this E due to 1 plus E due to 2 plus E due to 3. And we can write that as E due to 1 is K Q1 over let's call P1 squared. So that's the distance from the charge to point P plus K Q2, and again that's RP2 squared plus KQ3 over RP3 squared. And notice that my, let's see, let's see if it's gonna, there we go, okay. So this should be a P here. There we go, okay. So now remember that I said that for this first one, I'm going to have a positive because it's going in the positive x direction. This one's going to be negative, going in the negative direction, and this one's going to be positive. And I'm not going to worry about the signs of my charges here. I've already taken care of the signs by dealing with the direction, what direction the electric field is in. So when I plug in the numbers, I find that EP is equal to this charge here, 9 times 10 to the 9th times 6 times 10 to the minus 6 over, now look, my location here, this is going to be 2 centimeters. This distance here is going to be 1 centimeter. And this distance here, oops, wrong one. And this distance here is going to be 3 centimeters. Okay, so that's what I'm going to be plugging in. I'm going to pull the K out because K is in each one of these terms. That way I don't have to write it 3 times. So 9 times 10 to the 9th Newton meter squared per Coulomb squared. And then times Q1 is 6 times 10 to the minus 6 coulombs over 2. Double check that. Yes. Let's say 0.02 meters squared plus this Q2 is, I believe it's 1.5. Yep. 1.5 and minus 2, or 2. All right. Plus, this one's going to be 1.5 times 10 to the minus 6 coulombs over, and now this distance is 0.01 meters squared. That's the distance from our charge 2 to P. So that's this distance here. And then last but not least, I'm going to have plus 2 times 10 to the minus 6 coulombs over 0.03, and that's meters squared. Okay, so when I solve this, and remember this is a positive, this is a negative, and this is a positive. So I find that I get 1.35 times 10 to the minus 8, or times 10 to the 8th, excuse me, newtons per coulomb. And then I get plus a negative 1.35 times 10 to the 8th newtons per coulomb. And so these cancel, these two cancel, and I'm left with, this one turns out to be 2 times 10 to the 7th newtons per coulomb. And so my EP, my final EP is equal to 2 times 10 to the 7th newtons per coulomb. Okay, now it asks me, this is part A. Let me just write part A. And then part B says, if a charge of minus 2 microcoulombs is placed at this point, what are the magnitude and direction of the force on it? Okay, so we know, right now we know that this is in the positive x direction. Okay, so B, so force is equal to Q times E. And so now I'm bringing, let's see what my charge is. This is a charge of negative 2 microcoulombs. Okay, so I'm going to say this is going to be Q, so negative 2 times 10 to the minus 6 coulombs multiplied by 2 times 10 to the 7th newtons per coulomb. And this is going to be in the positive x direction here, but we have this negative. So the negative is going to, if I think about if I have a positive field here, if I think about my point P, and I have a positive field here pointing this way, then when I bring a negative charge, it's going to change the direction. So it's going to be, the force is going to be this way. Because if I bring a charge here, a negative charge here, this charge is going to want to go away from the electric field, so this way. So the force is equal to so if I look at the signs here, I have my negative 6 cancels with 6 of my 7, so I'm left with a 1. So this cancels, and I'm left with a 1. And I get 2 times 2 is 4. So I get 4 times 10 to the 1 is 40. So that would be 40 newtons. And again, the direction is to the left. Yes. So the direction is in the negative x direction.